Hi all, welcome to this webinar series from Chaos Renewables. So in this series, we are going to cover about solar PV benefits and risk, and also how you can go about choosing a good solar power plant. Before we start, I'm going to give you a quick intro of the topics which we are going to cover. I'm Shiva, Director Strategy for Care Renewables. So I'm going to take you through this webinar series. So we are going to divide it into multiple sessions. So we'll start with a summary of what we are going to cover in this webinar series and an introduction to solar PV in this session. And the other topics which we are going to cover are listed below. We will get to those in subsequent videos. So Chaos as a company was started in 2012. We have done around 300 plus projects in solar PV across 7 states, and we have done it through most of the projects are done through our service partners, which are around 80 of them are there, and they're spread across 7 states. We are also an MNRE training partner under SETNet. We have trained around 7,000 professionals and installers till date, and we have 6 research labs where we test solar PV products and work with research scholars in applied research in solar PV. That's a bit about us. Now coming to what we are going to cover in this webinar series, I'm just summarizing the benefits and risks here so that you get an overview before we jump into the details. So solar is a good investment with a return rate of more than 15%, and this applies to high consumption residential consumers as well as commercial, industrial, most of the consumer categories. So if you own a building and if you pay electricity bill, probably it's a good investment for you. And if you are talking about the design life, typically we talk about a 25-year design life for solar power plant. It's not true if the quality of the components are not up to the standard, and there are a few components which may fail. So we'll talk about in later sessions, but we can presume that a well-designed plant has 25 years design life, and your return on investment will depend on the tariff rate you are paying. Typically, based on your distribution company, whether it's KCB or TNEB or MESCOM or SESCOM, the tariff rate will vary, and also based on whether you're a commercial customer, residential customer, or industrial customer, your tariff will vary. So if the tariff is higher, you will have a quicker return on the solar PV investment. And if you're worried about the capital investment which comes with solar PV investment, there are many schemes offered by banks and other financial institutions which you can use to finance the solar PV project. Now coming to the risk, which is actually less talked about. There are a lot of bad quality systems, especially when it comes to rooftop, which we have come across. This leads to low design life and low returns. So typically the payback for a solar power plant investment happens after 4 years for most of the investments. So if the system doesn't last or doesn't produce sufficient power after 4 or 5 years, then it's a huge risk for someone who invests in solar PV. And solar can be a fire hazard. The system is not properly designed or maintained because we have high voltage DC in most of the solar power plants. So you have to be careful there. Another nowadays the most common power plant which is talked about is grid tied power plant, where we work with a distribution company, and this doesn't provide power backup even though it's a good investment. And the last point is when you have a lot of companies going bankrupt, whether it's installers who have done this, done bad quality systems, or a good manufacturer who might face financial issues and going bankrupt. So that's a serious issue in solar PV. So these are the risks associated with this. And towards the end, we will also cover how you can choose a good quality solar power plant considering these benefits and risks after factoring in the key performance indicators of the key components in a solar power plant, which is the solar inverter and the solar panel. Now going to the next session. So here I'm going to give people who are not so familiar with solar photovoltaics a brief view of what is solar and what we are talking about when we talk about solar photovoltaics. So sunlight has two components. So there is a heat component and a light component, and here we are going to be focused more on the light component, and the light is what gives us energy in a solar PV power plant, not the heat. Now I'm not going to get into technical detail of photovoltaic effect, but I believe most of you might have heard of it or learned it. So photovoltaic effect is when the photons or the light hits a photovoltaic material, it knocks out electrons, and you get electricity. So that is the basic principle which is used in solar PV panels. So what we typically notice, and everybody is familiar, will be the sun's position in the sky. So it keeps changing during the day. So is the radiation which we get, or the light which we get from the sun. So it keeps changing during the day. The sun will be less bright during mornings and evenings, and during the noon it will shine harder. So this is how the sun's position change during the day. So what this means for a solar power plant is it will produce less power during the mornings and the peak power during noon, and again lesser power during the evenings, and obviously there will be no power during the night. So what we understand from this is solar is not a constant source of power. So when we talk about a diesel generator or any other source which we typically come across other than the renewable sources, when we talk about 1 kilowatt of power, what it means is the system can produce 1 kilowatt of power at any point of time depending on the load. But in our case, the fuel for solar power plant varies throughout the day, because of which the power production which we get from a solar power plant changes constantly during the daytime. So it's a variable source of power. So for a typical sunny day, it will look like this. This is how a solar power production will look like. And if you go to a cloudy day, it will look like this, because the clouds will be moving, and you might have a very different pattern as well. So this is just an example. So now we have some kind of a problem at hand, because since Earth moves, the solar is not a constant source of power. So how do we utilize this power? So we can either complement that power and use it. So that is one way which we can do it. So we can use solar when it's available, and maybe use some other source when solar is not available. We can store it and use it. So that's another option. And there is also an option where we can maybe use it whenever it's available and discard it when it's not available. So that's a typical application of a solar pump, where the pump's output will vary based on the solar irradiation the panels receive. So these are the options. So it's very critical to understand that solar is not a constant source of power, and we always need some source to complement it. So in a grid-tied solar power plant, in an off-grid solar power plant, we store it, and the batteries kind of complement that solar power. So whenever there is a shortage in power, the batteries supply the excess power, and when there is excess solar power, that goes to the battery. Now when you talk about an off-grid system, so this is the first kind of solar power plants which was there in the market. So there are multiple components. So there is a storage component, and there is an inverter and solar panel. So these are the key components, so to speak. So one disadvantage of this off-grid solar power plant is its efficiency is very low. If you compare it with a grid-tied solar power plant, it's around 70%. And second one is, the capital cost for the system is very high because we have expensive storage batteries, and even the inverter cost is more expensive compared to a grid-tied solar power plant. And the third aspect is the high operations cost. So here the batteries typically have a life of 5 years if you're talking about a conventional lead acid battery, and 10 years if it's a lithium ion battery, and you have to replace those batteries after the design life. And the third aspect is, it's a positive one. Basically, if you have grid failure, you get backup with this kind of system. So this is now, these systems are now recommended more for areas where there is very frequent power outages, where a grid-tied system is not feasible, or where there is no power, like rural areas where the distribution company's power has not reached yet, or it's too expensive to draw the power lines. Those cases, this might be a feasible system. Now the grid connected system is the most popular one now in the market. So here we don't have any storage. We have inverters, solar panels, and it works. The discom power complements the solar power in a grid-tied solar power plant. So if there is a shortage of solar panel power in the morning, the grid power complements it. So that's how it works. And the positives are the system has very high efficiency. So, and the capital cost is low, and operations cost is also low. The disadvantage with this system is whenever there is a power outage, you don't get any power from the solar panels or inverter, because the inverter requires the KCB or TNEB or whatever region you are, BESCOM grid, to complement the power from solar panels. Otherwise it doesn't work. Now there is hybrid system, which is also kind of becoming common now. It's not very popular, but there are policies coming in for hybrid systems as well. So hybrid systems have multiple sources of power. So it's a mix between your grid tied as well as your off-grid systems. So we try and strike a balance here in terms of the backup power we get, as well as the cost which we have to manage in terms of the capital cost and operations cost. So this is, and theoretically you can have any source. You can have a DG, wind, any mix of more than two sources typically qualifies as a hybrid system. But in solar, when you talk about solar power plants, what it means is you have a backup power and you have a distribution company's grid, and both can work together. So this system will work with both the grid as well as the battery. So that's what we call as a hybrid system. So this has moderate cost in terms of operations and high capital cost. But the good thing with this system is you can use it whenever there is a power outage as well. There are certain other advanced functionalities which is a bit out of scope for a basic introduction to solar PV lecture. We will cover it in a later webinar. So this is like I said, there is a variability in terms of power production based on the radiation. But if you take for example, if I take the state of Kerala, this is how an average production per day typically looks like for a solar power plant for each month, for each day in that particular month. For 1 kilowatt of solar power plant, this will be the average production. This is actual data from one of our solar power plants. So you can see that it varies somewhere from 4.9 to a low of 3.2, and on an average we are getting around 4.05. So this is a typical system. So there are some cases where we get higher irradiation, or this plant I believe is in city of Trivandrum. So if you move to Palakkad or other regions where the radiation is slightly higher, even in Kerala, there might be a difference. In Bangalore, we typically get around 4.5 units, and in Gujarat around 4.7 units. So depending on the irradiation, there is a big difference in the production which you get from a solar power plant. So that's all I want to cover in this particular webinar. We will talk a bit more about net metering in our next session. Thank you.